Okay, I have combined sections 1 and 2 of 15 together because once again they are sort of connected with one another. They're talking about the biosphere and talking about climate and things like that. So the term biosphere we've already used a couple of times in here. So the biosphere includes all of the ecosystems on the planet. So, and it's just one of the Earth's 4 major systems. So the biosphere has in it the biota, which biota is all the living things in the biosphere. The biosphere is, when we talk about an ecosystem, again, ecosystems are all of the living and non-living things in it. So the biota is going to be all of the living things that are in the biosphere. There are 3 other systems. Like I said, the biosphere is one of the 4. The other 3 are the hydrosphere, which includes water, ice, and water vapor, the atmosphere, which is the air blanketing the Earth's solid and liquid surfaces, and the geosphere, which is going to be the geological features above and below the Earth, so like mountains and things like that. So all 4 of the Earth's systems are interconnected with one another. This is what is known as the Gaia hypothesis, and it considers the Earth as a kind of living organism. So Earth systems interact to yield a biosphere capable of supporting life, and this idea was developed by James Lovelock and Lynn Margulis. So in section 2, we're going to be looking at climates. So climate is a long-term pattern of weather conditions. If we're talking about weather, weather is the day-to-day atmospheric conditions, and climate is looking at the long-term pattern of those. So the things that fall under climate are going to be the average temperature, the amount of precipitation, the relative humidity. Key factors shape an area's climate. So that's going to end up affecting the temperature, the amount of sunlight that is received, the water in the area, the amount of wind. Within a climate, you can have what's known as a microclimate, and that is going to be a climate that's going to change from the larger area. So, for example, if you are talking about like a area and you've got a cave, and inside that cave from outside it's going to be different. Or if you're here in Lafayette and you go up to Chicago, it's going to be different climate because even a couple of miles in from the Lake Michigan, it's going to be different than right there on the lake shore. So that is what's known as a microclimate. The Earth has 3 main zones that are the 3 main climate zones are the polar, the tropical, and the temperate zones. The polar climate, the far northern and southern regions of the Earth, it's going to go from the poles down to about like 66.5 degrees. The tropical zone is going to surround the equator, and then in between the tropical zone and the polar zone are going to be the temperate zone, which is where we end up being located at. In the tropical zone, there's not going to be any seasons in that zone. So the temperate zone, we're going to have the 4 seasons in the temperate zone. So once again, here are the zones of for the climate on the Earth. The angle that the sun hits the Earth is going to determine the climate zone that it's in. So the polar zone gets the most indirect sunlight, as you can see in this picture. The temperate zone, there's going to be times where it's sort of direct and indirect, and then you can see at the tropical zone, it's going to be direct sunlight all year long. So that angle that the sun hits helps determine what climate the area is going to be. Another thing that comes into play with determining climate and the weather of an area is the Earth's tilt on its axis is going to play a role in seasonal changes. So as we go around the sun, it's going to cause the water and the atmosphere to heat differently. So solar heating causes movements of both water and air. So that's going to give you wind and the ocean currents. Earth's rotation also has effect on the wind and ocean currents as well. So land masses are also going to help shape inland climates. So larger temperature, you're going to have larger temperature changes. Uh, you may end up with less precipitation. If you're sitting on an ocean, the shape of the coastal that's going to help shape the coastal climate, and you're going to have small changes in temperature, higher humidity, more precipitation. So mountains are going to have an effect on the climate. Precipitation occurs on the side of the mountain facing the wind. The other side, the downside, is going to be drier and cooler air is going to produce a rain shadow. A rain shadow is an area of decreased precipitation. So you can see right here a western slope, and then the eastern slope of that mountain is completely different. So those are the major things that are going to drive the climates of different areas. And that's the end of the notes for section 1 and 2.